Hello guys, today I am going to explain ways to calculate pi and give some code examples. First we have this formula. With this formula, even if we use observable universe dimensions, we can only calculate pi's to 100 decimal place. We have Leibniz method. This method goes on forever. Nilkanta series is similar with Leibniz method. Ramanujan's formula. This formula is ancestor of Chodnovsky algorithm. Chodnovsky algorithm. This algorithm is most popular and fastest way to calculate pi. Machine-like formula is a popular way to calculate pi. BBP formula. With this formula, we can compute intended digits of pi in hexadecimal without computing preceding digits. Now I will show some code examples, and in this project I use GMP library and make a video about how to download it. You can look it up in description, and this code is in my GitHub and the link is in my description too. First we have Leibniz method. It's a easy method. We have if else and for loop. But in this method, after a point, it's almost impossible to improve the precision. So I quit this method. After that, I try Nilkanta method. First, I write a simple for loop and methods in itself. After that, I made it a bit complex and easy to interact with. And finally, I add GMP library. A GMP library is library for using big number. For example, in C++, we have long. It's 64 bits. But with GMP library, we can use, for example, 1000 bits integers or floating points or rational numbers. It's very cool library. For example, it's 1024 bit, this floating point. I made a video, you can look it in description. And after this, I made it automatic. It's write it to a file, this file. In the, I run this program for 4 hours, I think 4 hours, 5 hours or something, and the final result is this. I think 749. It's calculate this digits. And finally, I try to do Ramanujan and Chodnovsky's methods, but it didn't work very well. They are very complex and it's very hard to do code it. For example, this code is only I think 8 digits of pi. Can calculate 8 digits of pi. It didn't work very well. It's working, but uh, it's need a bit more work. I am doing this pi thing in like 3 weeks or something, and I want to keep continue. So I will just leave this Ramanujan Chodworsky method. This code is very fast and very good. I found it in GitHub and put it in my code. Yeah, that is for video. Go check the description and thanks for watching.